Good good afternoon, guys. My name is Gopinath from VIT College. Today I am going to discuss about some topics uh, in probability and statistics for subject in BTech. So now we are going to discuss. Now I am going to discuss about the difference between one-tail and two-tail test and test of hypothesis of single, comma, different small samples. Here, um, I am going to discuss about the small samples. Small samples. So there are two samples in the syllabus. One is large sample and another one is small sample. When if if we are going to determine a small sample, then the size of sample n is less than or equal to 30. So if we are going to determine a small sample, then its size must be less than or equal to 30. Now, let's see the difference between one-tail and two-tail test. And here, let's go through this. Yeah, one-tailed and two-tailed tests of hypothesis. A two-tailed test of hypothesis will always reject the null hypothesis if the sample static is significantly higher than if the sample static is significantly higher or lower than the hypothetical population. So here in two-tailed test, the rejection region will be on the two sides of its tails. The name itself determines the name itself determines it. The rejection region will always be on two sides of its tails. Here, two sides of its tails. Let us see. So, what is meant by a rejection region and what is meant by an accepted region? The level of significance determines the rejection percentage of a given item or given paper or something. Okay. Here, normally we always take 5% of level of significance by default for testing is sample. And here, since it is a two-tailed test, so normally it is 5%. 5% means 0.0 0.05. Since it is two-tailed test, so we need to divide this by two equal parts. So we get this 0.025 and the other half is this 0.025. And remaining, this one is known as acceptance ratios. So the graph shows the normal distribution curve, and this is the mean. The middle one is the mean, and here this is the 50% of the region, and this is the 50% of the regions. The 0.475 and that for 0.475 are the acceptance regions, and the rejection regions are the two tails of left and right tails of the graph shows the rejection regions of two-tailed test. And now let us go through the next one. This is the five-tail test. So this is the five. This is the test when level of significance equals to 5%. And normally the level of significance normally we can calculate the level of significance by default at 5% and 1%. Now let us see the 1% significance, 1% level of significance. This graph shows the proposed graph shows the 1% level of significance of two-tailed test. Here 1% means 0.01. So by since it is a two-tailed test, we have to divide it by half. So the two tails get the equal amount of level of amount of rejection region. So since it is 0.005%, 5% of 0.005 rejection region of two tail, two tails, and here one. Let us go through the one tail. One tail means the rejection region will always go through on left side, left tail of the graph, or right tail of the normal distribution graph or normal distribution curve. Here at the 5% 5% level of significance, see here the left side graph shows the right tail of 0.05 rejection region, and right side graph shows the left tail of 0.05%, 0.05 rejection region. See, here one tail graph is a unidirectional graph since it has the left or right directions, and the below values are the critical values for the two-tail test or right one-tail test or right or left tail test. These are the tabulated values of the level of significance for the corresponding level of significance. And there is little more there is in order to identify whether the whether the given information consists of a right tail or left tail. With right tail or sorry, one tail or two tail, we can identify those by these keywords. If the question contains less than, more than, greater than, smaller, excess, superior, inferior, increase, decrease, at most, only, or improved, or excess, exterior, under, both. So these kind of keywords in the question they have mentioned. So blindly go through the one tail test. So for a right hand tail, we go through the keywords like more than, superior, better than, at most, increase, and so on. So and for left tailed test, less than, less, smaller than, so thinner, decrease, and so on. If they don't mention any of these keywords, then blindly go through the two-tail test. And now I'm going to discuss about the steps to follow the test of hypothesis. Before that, since it is a small sample, as I mentioned before, the small sample size is less than or equal to 30. So Here, for the small samples, we can for the small samples here a single small sample. Here we have two conditions. If the standard deviation is not given, or the standard deviation is given, but sorry, if the standard deviation is not given, then use this formula: T equals to x bar minus mu by s by root n. Here, for sample, we use s as standard deviation, comma, and x bar x bar as mean, and for population sigma as standard deviation, and mu as mean. So here, and here we can calculate this t value based on these formulas. If the standard deviation is given directly, then we may use the t equal to x bar minus mu by s by square root of n minus 1. Here, n minus 1 represents the degrees of freedom. And let us see the process. Let us see the process. Is a test of significance for single mean. It is also known as the student's t-test. So we are in order to testify the hypothesis, we may follow the 5 steps. First one, the null hypothesis, or it is represented as the H0. So here x bar equal to mu. That is, there is no significant difference between the sample mean and the population mean, or the sample has been drawn from the population. Here it is a statement, it is an assumption. We consider it is an assumption. There is no difference between the sample and the population means. Here we have taken that as an assumption. And alternate hypothesis H1 represents it is quite opposite to the null hypothesis. So if we are assuming the statement true in null hypothesis, then it automatically replies the false in alternative hypothesis. So like one see here, x bar is not equal to mu. This statement refers to two-tailed test, and other statements are x bar less than mu represents the left-tailed test, and x bar greater than mu represents the right-tailed test. This is the second step to have to follow. And let us go through the third step here, the level of significance. As I mentioned before, the 5% of level of significance is a default significance. If in a question they won't mention the level of significance, so blindly go through the 5% level of significance. Okay. Level of significance means the failure or rejection percentage of a given work, or failure or rejection percentage of a population. The first step is test statistics. We have to test the given information equals to t equals to x bar minus mu by s plus square root of n minus 1, or x bar minus by s by, and here the conclusion. When here, if what t, here what t means the calculated test statistic. Here the test statistics may have may gives the negative values along, may gives the negative values along with the positive values. So in order to minimize the negative value, we follow the modulus here, and here mod 2 or mod of t calculated less than 3 alpha, or t tabulated value. We accept that null hypothesis. Otherwise, we reject the null hypothesis. Let us go through the problems. So, the average breaking strength of a steel rod is equal to 18.5 thousand pounds. To test this sample of 14 rods per test, the mean and standard deviations obtained were 17.85 and 1.995 respectively. This is the result of experiment signal. This is the question. So here the given n equals to 14. So the size of sample equals to 14. And here the total population or the total amount of mean equals to 18.5. And here they have mentioned the mean and standard deviations obtained. These are the sample mean and standard deviations. So we may consider as x bar and s for the samples. Now here to test the hypothesis, we do follow the 5 steps. First one is null hypothesis. So accept x bar equal to mu. So mu equal to 8.8.5. Okay. Then the alternate hypothesis. Since in question there is no keywords regarding the one tail or two tail test, so we blindly follow it is a two tail test. So mu not equals to 18.5. Here, level of significance alpha. The level of significance is denoted by alpha. Since they hasn't mentioned the level of significance, we defaultly we blindly choose alpha equal to 0.05 or 5%. So since it is a two-tailed test, alpha by 2 equal to 0.025. So let us calculate the test statistics. We calculate equal to. Here the standard deviation is given directly. So we may proceed with this formula: x bar minus s by n minus 1. So substitute the values and we get here the answer minus 1.19. So we have to alpha the interval. So here we are the modulus. The base of freedom is defined as the size minus 1. So here the size is 14 rods. So here the size is 14 rods. So degrees of freedom is 14 minus 1 equal to 30. And tabulated value of t. Here let us see it in the tabulating. So here degrees of freedom equal to 30. And we are choosing 0.05 as the level of significance. Let's go through the table. sorry. Since it is a two-tailed test, I am going 0.05 level of significance. Here, I got the degrees of freedom as 13. So choose here the corresponding value. This is the calculated value, 2.160. Go back to the page. Here, mod of t calculated equal to 1.198. So the conclusion, t calculated is less than the t tablet. So null hypothesis is accepted. This is the procedure we have to follow all the problems. Let's go to the next. Here they have given a new process of producing synthetic diamonds can be operated. Here they have mentioned greater than, here excess means it is a right tail test, one tail test, and further we can say that it is a right tail test. So according to the data, so sample equal to n equal to 6 and x bar mean according to the given data, I have calculated x bar equal to 0.5316 per cals and 0.5 is the mu. So for this, I have calculated the standard deviation based on this formula, and we get 0.05. This whole calculation is based on the cals. Okay, let us go to the problem, and we have 5 steps and hypothesis. So x bar equal to mu equals 0.5. And here alternate hypothesis. Since it in question they have mentioned the greater or excess, so we may go through the right tail test. Here they haven't mentioned about the level of significance. So by default, I take alpha equal to 0.05. And here haven't mentioned the ST standard deviation. So I have wrote this form S by root. So after substituting the values in this formula, I may get this one 1.4604. And here a decrease of freedom will be 6 minus 1 equal to 5. Here the tabulated value as shown in the this is the 2.015 as per the tabulated values. And here we get calculated value is less than the tabulated value. So null hypothesis is accepted. This is the problems and this is the concept regarding the test of hypothesis of a single sample. Now we are discussing about now we are going to discuss about the test of hypothesis for different small samples. Test of significance for difference of students, teachers, peers. So the procedure will be same, but the formulas may change. Null hypothesis H0 mu1 equal to mu. That is, there is no significant difference between the two means. And alternate hypothesis mu1 not equal to the mu is a two-tail test. Alpha set a level of significance. Okay, test statistics. We may use t equal to x bar minus y bar by s into square root of 1 by s n1 plus 1 by n. and s square equal to, this is the formula. Here the level of significance, sorry, degrees of freedom is known as n1 plus n2 minus 2. This is the degrees of freedom. And the process is same. If a standard deviation is given, we may use these formulas. And if standard deviation is not given, we may use these formulas. That's it. Okay, let us go through the next. Let us go through the formulas. So let us go through the formulas. And here, samples of 2 types of electric light bulbs were tested for a length of life at the following interval applied. Type 1 type. They have mentioned the clearly sample number. So here sample number n1 equal to 8, n2 equal to 7. Okay. Sample mean, sample ST. Okay, what's the question? Is the difference of means sufficient to the begin that type 1 is superior to the type? Here we get the keyword superior. So here type 1 is greater than type. So here greater than superior means it is in right tail test. So as per the given values, have we substituted it in the formulas and we get is equal to square root of n1 into s1 squared plus n2 into s2 squared by n1 plus n2 minus n2. Sum is 40.731. Go through the sum. Go through the process of the hypothesis. U1 equal to mu. An alternate hypothesis. Since it is a right tail test, we choose u1 greater than mu. And they haven't mentioned about the level of significance, so I took alpha equal to 0.05. And as per the formula, I substituted the values and I got 9.3924 is a T calculated. And here the degrees of n1 plus n2 minus 2. I get 30. I got 30. So here the T tabulated value equal to 1.771. Okay, 1.771. Let us go through the table. It is a one-tail test and it is a one-tail test and 0.05 is the level of significance and 13 is the degrees of freedom. So I got 1.1771. 1.771 as the value. T calculated value. See 1.7. Here, T calculated value is less than the tabulated value. So null hypothesis is rejected. Same applies to this next problem. Here they have given two random samples of sizes n1 equal to 9 and n2 equal to 7 under the respective means. See the sum of squares of deviations from the mean are. Here they have given these values for the standard deviations. So we have to read the question carefully. Here we have to do the process. Since it won't given the standard deviations, we have calculated the standard deviations for this. And here they won't mention any keywords like greater than, superior, or like that. So we have feature it as a 2 test and alpha equal to 0.05, and here the formula is changed. But here we get by substituting the values, we get the t calculated equal to minus 2.6368. So we have to modify the negative value. We put 10 modulus. The degrees of freedom will be the 14. Here the tabulated value for this one is 2.145. So check the degrees of freedom 14, and since it is a two-tailed test and 0.05 level of significance, go through the column and pick that value 2.145. Here the calculated value is greater than the tabulated value of t. So null hypothesis is rejected. Okay, friends, this is the brief discussion about the topics regarding difference of one-tailed and two-tailed and test of hypothesis of single small sample and different small sample. Thank you one and all. Thanks for watching. Signing off.